13 from 4.4 homework. Is everybody with me? So this is what you're using for second fundamental theorem of calculus. Everybody with me now? All right. It says, what does it say? Second fundamental theorem of calculus says what? Remember, this is what we're supposed to have, right? That's the second fundamental theorem of calculus. So we're supposed to take antiderivative, and then what do you do? Take a derivative of that. Are you with me, class? So I have this. All right? So what is derivative of x squared? 2x. Am I right, class? 2x? Okay. So first thing first, I'm gonna make this into a, I'll just do just like this, I usually do, right? So I'll do f of t is 1 over t to the 5th, I will use the same as what? T to the negative 5, right? Because if you want to take antiderivative, you need to make sure to that to be what? Power, in terms of power that we can do. So we have that. So everybody see that? Okay, this person is going a longer way.
Yeah.
Yeah, this person is going a longer way, but it's okay. So what that, here's our alternative. This is what I'm trying to do. This is when you do a longer way. I'm glad they're showing both of it. Okay, this is what it is. If you, it says what? Take antiderivative first, and then what do? Take a derivative. So this is what they're doing here. Take antiderivative of this. Antiderivative of that will be what? Negative 4 divided by negative 4. Are you with me, class?
Let's subtract 1.
Is everybody with me? Negative 5. Adding 1 power give you negative 4. Negative 4. Are you with me, class? Are you following me? Take, when you do that, so since it's negative 4 power, you put it into where? Denominator to the positive power. And then you're going to plug in what? X squared in here. So the x. So you have a t. I'm going to replace t with what? X squared. So I have a 4 x squared to the how many? 4 power, which gives you what? 4x to the what? 8 power. That's why you got 8 power. Is everybody with me? And then you just simply plug it in a number, you get this. All right, that's good. Now, take a derivative of that. Okay, this is the same as negative 1 over 4 x to the negative 8 plus 1 over 324. Is everybody with me? Can I rewrite this problem as power? This is x to 8. It's a denominator, so I need to make it to be what? Negative 8. Are you with me, class? Take a derivative of that. You get what? Take a derivative of this. What do you get? This. Which is negative 1/4 times negative 8 times x to the what? 1 less power. So how many power is that? 9 power. And you multiply this together, what do you get? 2x to the what? Negative 9, which is the same as a 2, 1 over what? X to 9, which is the same as what? 2 over x to 9. That's what you have here. It's a long way, very long way. But we learned that from what? Fundamental theorem of calculus. What's the better way? Just use what? Theorem. Theorem says what? This is kind of like, they're kind of like a canceling out. And the only thing I gotta worry about is what? The upper limit, take a derivative of that. Take a derivative of x, it's just the 1. No big deal. But if we have other than x, like x squared, what's the derivative of that? 2x. Okay. So this is what they're doing. So does everybody understand? This is x squared. I'm replacing x with what? I mean t with what? X squared to the what? 5th power, right? Negative 5th power. Now what do you have to add? What do you have to multiply? 2x. Where does 2x came from, class? X squared. Did you get the same answer?
Wow.
Yes. So which one is easier for you?
That
This
one.
or this?
Oh my goodness.
Are you with me? You see why is a fundamental theorem of calculus, second fundamental theorem of calculus so important? You save you so much what? Time and energy. Look at all the
Wait.
steps that you gotta do. Yes.
Okay. Where you say the 2x came from? That's the
Derivative.
Derivative of that x squared. So simply, I'm gonna replace t with whatever that is, right? So x squared to the negative fifth. But I need to make sure I take a derivative of my upper limit. What is that equal to? 2x. So this is the same answer as that one. You get the same answer. So I'm glad they're showing you both. The better one to me is this one because this is what I'm simply just using what? Theorem, the second fundamental theorem of calculus. All right, that's what I want to show. So do you understand what I'm talking about? What the second fundamental theorem of calculus? Yes, yeah. Go ahead.
You just gotta put the x squared to the negative fifth in the calculator to get negative 9.
Do what? Do again?
How you get -9 from that?
Oh, how did you get that? All right, so 2 times here.
Thank you. So,
All right, this means what? 10 power? X to the negative 10 power times 2x to the what? 1 power. So negative 10 plus 1 give you what? Negative 9 power. So that's why you have 2x to the negative 9. So you get this one. Are you with me, class? You get the same answer. So I would definitely like to use what? This, using the second fundamental theorem of calculus. All right, everybody good? So do your homework, class. Otherwise, you don't know what to ask. Do your homework, okay? Now we'll see you tomorrow for 4.5, and that's our last of that section for chapter 4. All right, you guys have a good day.